Hello everyone, today we are going to talk about JMC 2015 and it's going to be the second half of this paper, alright, which is questions 16 to 25. So let's take a look at what questions we have today. Okay, so let's move on to question number 16, which is where we should start with. So this question, obviously, if you just take a look at it, it's going to be about angles, right? So it's a geometry question. And I would say that it's on the interior angle and exterior angles. Interior and exterior angles. All right, so now what do we know from this question? We know that it is a square inside an equilateral triangle, right? Which means that for squares, we know that all the angles, they should be right angles. And for an equilateral triangle, we know that all the angles, they should be 60 degrees, right? Not this one. Okay, so the next step we can see is that if I'm just considering this quadrilateral on the top, it's going to have an interior angle sum of 360 degrees, right? So let's say this angle is angle A and this angle is angle B, where this angle adding a right angle is 360 degrees, which means that this is 270 degrees. Now we have an equation, A adding B, adding 60 degrees, adding 270 degrees is 360 degrees, because that's the sum of interior angles for a quadrilateral, which means that A adding B is equal to 30 degrees. Now we can also see that X is forming a straight angle which is 180 degrees with 90 degrees and the angle A. So that's 180 degrees, which means X adding A is 90 degrees. On the other hand, we have Y adding a right angle adding B is going to be equal to 180 degrees as well. Which means Y adding B is also 90 degrees. So now if I'm just to combine these two equations together, we'll have A adding B adding X adding Y equals 180 degrees, right? That's the two 90s added up. Also, we know that A adding B is 30 degrees, which means that X adding Y is going to be 180 take away 30. That is 150 degrees. So the answer is going to be D for this first question. Okay. And then for question number 17, so this is pretty much an interesting question. I would say that it belongs to the miscellany module. And it's going to be the logical deduction questions, and to be specific, it's about the truths and lies. Okay, so if you read these four statements, well, the hearts said that he stole the tarts, and the club said that the heart is lying, diamond said that the club is lying, spade says that the diamond is lying, which means that every two of them are contradicting with each other, right? But then you can see that if the knave of clubs is in contradiction with both the hearts and the diamonds, it means that the hearts and the diamonds must be either true at the same time or false at the same time, right? So heart and diamond, both true or both false. And also the knave of diamonds is in contradiction with both the clubs and the spades, which means that the clubs and the spades are also going to be either both true or both false. So as a result, when the hearts is true, when what the hearts is saying is true, it means that what the diamond is saying is also true. And the other two will be false. Well, if the heart is false, it means that the diamond is going to also be false, where the other two is going to be true. So there will always be two of them which are telling the truth, either hearts and diamonds or clubs and spades. Two of them. All right, so that's why the answer is 2. But we don't know which of them is actually telling the truth. We just know the number of them telling the truth. And then for question number 18, so this one is, I would say, pretty simple. Is a numbers and operations question on fractions. So you just need to use a little bit of observation in this question. Well, these fractions are certainly large enough such that it would be hard for you to, like divide the denominator by the numerator. Of course, you can do that to find the denominator as in its simplest form, right? Or to express it as like dividing the numerator by the denominator to give a fraction and then convert it back to give a decimal and then convert it back to a fraction. That's okay. But it would be really unrealistic in this question because like the numbers are too big for you to do that. Or of course you can just try to find the simpler equivalent fractions. But the thing is that you can see that in the numerators and the denominators, both of them are just in a multiplying 2 or a double relationship, right? Like the numerator is double the first one and the denominator is also double the first one. So it means that these two fractions are essentially equivalent, which means that if they are simplified, they would be simplified to the same fraction, which is a 7th. So that's how we can solve this question quickly. No big deal, all right? Just identify that they are equivalent fractions and you will see that they must be simplified to the same equivalent fraction in its simplest form. And then question number 19. So question number 19 is also a numbers and operations question. And I would say that this is not really much a good question because all we need to do is just to try it out. I would say that for this question, just do trial and error to see which of these cubes can be written as the sum of 3 positive cubes. That's all. So, of course, if it wants to be a sum of 3 positive cubes, these cubes must be smaller than that, right? So for 27, well, the smaller cube than that are 8 and 1. But then 3 of 8 is still smaller than 27, which means that it is unrealistic, right? So we can't have 3 positive cubes added up to 27. And then as for 64, well, this time 3 of 27s is greater than 64. But then if you are replacing one of them with 8, then what you get is 54 adding 8, which is going to be 62, and that is smaller than 64. Which means that none of these sums is adding up to 64 exactly. So 64 is not the answer either. As for 125, if I'm using 164, and even if I'm adding 2 27s, it's still smaller than 125. But if I'm using 2 64s, even if I'm using a number as small as 1, it is still greater than 125, which means that no sum is going to be getting to 125 precisely. Okay? And finally, the next one, 216, which we can see that it is 27 adding 64 adding 125. So you just need to do some trials and errors for this one. there's no proper analysis that we can do. Not that I know. So I would say that this is not really much a good question, but, well, it's just a question that was put in one of these papers. So I really don't like this question very much. So that's it. That's it for this one. And then for question number 20, I guess I need to hide my head for now. So I would say that this is a geometry question on surface areas. And to be specific, it would be using the three views analysis. So basically, the three views analysis is applicable for rectilinear shapes that are in 3 dimensions. So rectilinear solids, you can understand it as rectilinear solids, such that it will have 6 different views, right? We have the front and back, top and bottom, left and right. So there are 6 different views for rectilinear solids. And if I'm just adding up the area of all these 6 views, given that there are not any hidden faces, which means that all the faces are exposed to the views, you will be able to get the total surface area. So in this question, to be specific, you can see that this pyramid is rotationally symmetrical, and all the 4 side views are going to be the same, right? Which is 1 square stacked on top of 2 squares, on top of 3 squares, on top of 4 squares. So that's going to be the side view. And the area of that side view is 1 adding 2, adding 3, adding 4, that's 10. Where when I'm looking at the top or bottom view, if you look at the top view, it's going to look like something like that, right? But the area is just counting the largest square on the outside, which means that essentially it will be the same as the bottom view, which is a 4 by 4 square. Just like that. So it's having an area of 4 times 4 equals 16. So now we know that there are the top and bottom views, and there are the 4 side views. So the surface area is just going to be 2 times 16, which accounts for the top and bottom, adding 4 times 10, which accounts for the front, back, left and right views. So altogether, that's 32 adding 40, which is 72. So the answer is 72 square meters. Okay? That's how we can use the 3 views analysis to find the surface area of it.